Okay, today we're only going to have one assignment. That's going to be EE4. I'm going to try to slow down and do one IXL per day, and maybe or one Delta Math. This is going to allow people who still owe me stuff, and there's quite a few of you guys, to get to work and get those turned in. All right, so square root 5 squared. Well, these two are inverse functions. So when a square root and a squaring will cancel each other out. And we can see, because another way to write this is the square root of 5 times itself twice. Square root 5 times square root 5 would be square root 25. And the square root of 25 is just 5. So our shortcut should be, when we see a radical being squared, get rid of the radical and just keep the radicand that was underneath. Okay, now we've got square root 2 times square root 6. I like to think as the shortcut is I'm going to have a 2 and a 2 in here since they're both divisible by 2. Eventually that's going to come out. And you can see square root 2 times square root 6 would give me square root 12. Okay, since I had a 2 and a 2, I know there's going to be a factor of 4 that we can take out. So I'll break this up into square root 4 times square root 3. Square root 4 I can take. It's going to be 2. Square root of 3 I can't, so it stays underneath the radical. Okay, so 2 square root 3. Same thing again. We've got square root 6 and square root 3, or not the same thing. We got a different number, but I see both of these are divisible by 3. So if I have a factor of 3 and another factor of 3, I'm eventually going to be taking out a 9. Square root 6 times square root 3 is going to be square root 18. Okay, now square root of 18 can be broken up into square root 9 times square root 2. Square root of 9 I can take. Square root of 2 I can't. So square root of 9 is 3 times the square root 2 is going to be simplest radical form. Okay, now, like I said before, root 15 times root 15, okay? When you square something under a square root, we're just going to be left with the what's underneath. And we can prove that root 15 times root 15 is square root 225. And the square root of 225 is, of course, 15. Root 2 times root 5. I don't see anything in common in there. So when I multiply them together, I'm going to get square root 10. The only perfect squares other than 1 less than 10 are 4 and 9. And 10 is not divisible by 4. It's not divisible by 9. So square root 10 is simplest radical form. That's it. Okay. Square root of 8 times square root of 3. Okay. I don't see anything in common in them, but I know square root of 8 isn't simplified. So square root of 8 times square root of 3 is going to give me square root 24. And square root of 24 is divisible by the square root of 4. Okay. So I'm going to write this as square root of 4, square root 6. Square root of 4 I can take. It's 2. Square root of 6 I cannot. And there are no perfect square factors other than 1 left underneath that radical. Okay, now score is getting up around 50, so they're going to throw in some variables. Nothing's really going to change here, though. Okay, we've got 15 and 14. So these numbers, I don't see anything in common, and they don't have any perfect square factors in there. So these numbers are not going to have any perfect squares in them. But I do see a J and a K. Okay, so in this case, we're going to multiply, and so I'm going to change things since this is 2 and 7. And this is 3 and 5. I'm just going to rearrange these to make life easy for myself. 7 times 5 is going to be 35. times 2 is 70. Okay, so 70 times 3 is going to be square root 210. Okay, now j to the first times j to the first gives me j squared. K squared times k to the first is going to give me k cubed. All right, so 210, since I've looked at the factors, there was a 2, a 3, a 5, and a 7. There's no perfect squares in there. I'm not going to be multiplying the same factor times itself again. So square root of 210 is actually simplified. But j squared we can take. And I can't take k to the third, but I can break it up into k squared times k to the first. Okay, so, and then of course times the 210. Square root of j squared is j, square root of k squared is k, so those are going to stay on the outside. Okay, but underneath I'm still going to have 210k. Okay, so j and k will be on the outside. 210, we can't simplify in any way, so it's going to stay on the stay underneath, and 1k will stay underneath as well. Okay, so these numbers are going to get pretty big, so sometimes I'm going to want to break things up rather than multiply them together. So I just want to look at 343, and 343 is divisible by 7. If I can break that up into square root 49, okay, times the square root of 7, okay? Now, rather than multiplying that together and getting a number around 15 or 1600, okay, I can now break them down before I start and keep my numbers small. So the square root of 49 I can take, it's 7, but these two can now join together underneath the radical. We've got 7 square root 35. So the way these problems are going to get difficult is either there's going to be variables involved, or the numbers could potentially get pretty large before we have to simplify them. My suggestion is break them down before you multiply. Okay. Here again, we're looking at 70 and 3. 70 does not have any perfect square factors in it. It's not divisible by 3, so we're not going to get any more when we put these two guys together. So just like the same number we had before, 70 times 3 is 210. Okay, 210 only has 7. 10 can be broken up into 2 and 5. So if you've got a 7, a 2, a 5, and a 3, there's no perfect squares in common there. Now here we're going to have w to the 7th. W to the 7th is not a perfect square, so we're going to have to break that up. And x to the 3rd. Okay. Now we're going to break this up into the largest even possible. So w to the 6th times w to the 1st. And then I'm going to break this up into x squared times x to the first, square root of x to the 1st. This is a perfect square, and so is this. And the square root of w to the 6th is w cubed. The square root of x squared is x. And everything else that's left over stays underneath the radical. So I know there's a lot still underneath there. It's okay. So square root of 210 wx. So we've got w to the 3rd power x times the square root of 210 x. That's essentially as difficult as it's going to get. The only way they're going to get more challenging is if the numbers get bigger or there's more variables inside. Now, this we can use the shortcut. If anything is under a square root and it's being squared, then the answer is just going to be what's underneath the radical. So 10 w to the 2nd power. Okay. So as this is going to become challenging, you guys can see that they're doable, even though the numbers will get bigger. Let me finish with one more I'll get my score into the 70s and then we'll call it a day. We've got a root 5 and a root 5. So I know those are going to come out. So root 5 is going to give me times root 50 is root 250. But since I know that they were both divisible by 5, I know a root 25 will come out eventually. Okay, now I have actually, you know what? Just to save time, I'm going to break it up now. I'm going to say this is root 25 times root 10. And I'm going to break up v to the third into v squared times v to the first. And then I'm going to break, well, I don't need to break up the w, so it's an even exponent, so I'll just leave that underneath. I have a perfect square here, a perfect square here, and a perfect square here. So square root of 25 is going to be 5. Square root of v squared is v. Square root of w to the fourth is w squared. And what's left underneath is the square root of 10v. Okay, so 5v w second power times the square root of 10v. Okay, so this is what we have to do today, just EE4. I'm going to make a target score of 80 today, since this is kind of a difficult unit. I'm going to leave you guys with the rest of your time to try and focus and work on anything else that you may owe me. And if you don't owe me anything, then enjoy a nice, easy day.